Sean! You okay? Sean!
Oh,
do you see
I'm
that?
fine. Wait.
Over there.
Oh, I see it. Let's try it. Man, I can't believe I just did that.
Yeah, that was really embarrassing, man.
I bet you couldn't do any better.
I could, if I knew how to do it.
That's what we're here for.
Whoa! Who are you?
We're the PMP. Projectile motion police, that is. Sean, do you even pay attention in physics? You clearly didn't use the right projectile motion. First things first, you gotta split your variables into x and y direction. Also, velocity in the x direction is constant, and acceleration in the y direction is constant at negative 9.8 meters per second squared. And since time is a scalar, it's the same in both directions.
Wait, I don't get this. Can you show me?
Sure, let's go to the whiteboard.
We already know that you have to split it into the x and y direction, so let's start with the x direction. You know that your change in position equals 3.2 meters per second, and the velocity in the x direction equals 3.0 meters per second at a constant rate. The velocity in the x direction equation equals the change in position over the change in time, and you're solving for the change in time, which is in both the x and the y direction. So the change in time is 1.1 seconds.
Why does it have to be in the x and y direction?
Because the y direction is in free fall, and because of that, we know that the acceleration in the y direction is negative 9.8 meters per second squared, and the time is the same as the x direction because it's a scalar, so the time is 1.1 seconds, and the pig is 0.6 meters off the ground, and we're looking for the velocity initial in the y direction. So you can use the UAM equation of the change in position in the y direction is equal to the velocity initial in the y direction times the change in time plus 1/2 the acceleration in the y direction times the change in time squared, which comes out to be that your velocity initial in the y direction is 5.9 meters per second. And now we're solving for the total initial velocity using the Pythagorean theorem, which is a squared plus b squared equals c squared. You substitute in both the initial velocities and you solve for the total initial velocity, which ends up being 6.6 meters per second. Next you use TOA to find what theta equals. When you substitute everything in, you get theta equals 29.1 degrees. Your final answer is 6.6 meters per second at 29.1 degrees above the horizontal. Let's give it a try, Heath.
Bro, you gotta increase your angle.